So the topic of this talk is smart contract paradigms. Smart contract became a buzzword recently. Basically, every non-trivial piece of functionality is called a smart contract. And smart contracts are touted as a solution to pretty much everything around security and trust. In this talk, I will try to give overview of different approaches of smart contract programming, smart contract basically applications, and identify some limitations of this technology. No? Oh. So let's start with definition. The term was coined by Nick Szabo in 1995, something like that. His definition is a bit too technical, or maybe too legal. So let's break it down. First of all, by smart contract, we mean a contract in legal sense. That is, it's an agreement between two or several parties or more parties, not just any kind of program which lives in the blockchain. Then a smart contract needs to be formalized in code, so it's machine readable. Or maybe it can be a combination of a code with some legal text and so on. And it must be automatically executed and automatically enforced. This is basically the main motivation for smart contracts is automation. We know that legal contracts, they are like really unpleasant to work with. They take a lot of effort to basically create and to enforce. And many deals do not happen because there's just too much overhead. And so basically smart contracts are designed to automate these things and make them more efficient so we can do more stuff. One example which is given by Nick Szabo is a vending machine. You insert a coin and you get a snack. And no human is involved in this transaction. It's completely automatic. And it allows, of course, there are many vending machines where there are no human sellers, so it allows us to do things more efficiently. So even, of course, a smart contract is not really tied to the blockchains, but in the blockchain space, they really flourish it, because on the blockchain, we deal with digital assets, and enforcement becomes trivial. Basically, we just move assets on the blockchain, and even the first blockchain had some support for smart contracts. Bitcoin uses UTXO model. It keeps track of unspent transaction output set. Unspent transaction output is also called the coin. So basically it keeps track of value of a coin and the condition which is needed to spend it. Basically this script defines who can spend it, how can spend it, and when. So for example, the simplest example is user provides a signature of a transaction. Script verifies that it conforms to a public key and allows him to use this coin in a transaction. In other words, to do a payment. So the script, let's notice the script, it can only reply yes or no. It cannot modify any state. It cannot read any external state. It's just given a piece of data and it returns yes or no. So this is called the predicate in mathematics. So yeah, it can be used for things, of course, other than just a simple wallet. For example, you can define a bounty, which is paid to somebody who found a hash collision. To do this, you have a script which takes two values, hashes them, and checks if the hashes are same, and then it unlocks the coin. This basically, you can create a bounty for cryptographic research. You can also do many other things, like you can have a will or dispute mediation on the chain. You can do a trustless exchange using cross-chain atomic swaps, assurance contracts, and so on. There is a list in a wiki. So the contract bounty, it is a smart contract as in form of script. But in other cases, let's consider atomic cross-chain swap. So let's say Alice wants to sell one Litecoin for 45,000 Dogecoins, and Bob is the other party. They want to do it in a trustless way. They can do it using scripts on the blockchain, basically hash-locked scripts. There is an example here. So the way it works that when Bob claims his Litecoin on the Litecoin blockchain, he will reveal a pre-image which Alice can use to claim her Dogecoin. So either both transactions happen or none of them happen. This is why it's called atomic. So basically, in this case, the smart contract is the whole interaction. If you look at in the script, it doesn't have a notion of price or what is being exchanged. It just defines a cryptographic condition for spending a coin. So basically, the script is actually the smart contract is the whole thing. Basically, smart contract implementation consists of wallet logic. I guess the bulk of it is actually in the wallet logic, communication network, and parts in the blockchain. And these parts, basically the scripts, control only authorization and enforcement logic. This is not really a full smart contract. Smart contract is a whole thing. Yeah, but of course, Bitcoin model is very limited in many different ways. There are generalizations, some companies trying to extend it. For example, R3 Corda, they made a pretty much universal smart contracting engine using also UTXO model. Then yeah, Peter Todd is taking more like theoretic approach, also very interesting. But yeah, Vitalik Buterin was frustrated with progress of this Bitcoin basically upgrades because it takes a lot of time to do something to convince people to implement some small feature. So he wanted something infinitely flexible. So for this purpose, he took a general purpose programming model where you have a virtual machine with opcodes, basically a compiler. You have a persistent state and basically message passing and inserted it into the blockchain. So basically the idea is that when code is on the blockchain, when you want to upgrade, you just upload the new code, deploy it on the blockchain, and you have new features. So of course, this model, it can do everything which Bitcoin can because it's Turing complete. It can implement any kind of blockchain logic. So it's like the more powerful. So in a bit more detail, on Ethereum blockchain, we have programs which are called contracts. They consist of code and some data in form of key value store. And they can call each other using like function calls. So yeah, the question is this program, is this a smart contract? Yeah, maybe in some cases, yes. And usually Ethereum developers, they call them smart contracts. But yeah, like I mentioned that in some cases they are not, because smart contract, it's like agreement between people. It's something which means sense to people. And programs do not always make sense to people. Maybe smart contract will be implemented as in several contracts spread across multiple blockchains, wallet logic, and so on. And basically, we shouldn't equate, basically, if you take original definition, we shouldn't equate Ethereum contract with a smart contract. We compare Bitcoin style smart contract programming model with Ethereum style. So as you see, like with this Bitcoin style, we put as little as possible on the blockchain because blockchain space is very scarce. This is very precious resource, so we want to put this consensus part, just very basic authorization enforcement logic. With Ethereum, we get much more flexibility. We can put bigger amounts of code, we can put actual data on the blockchain, and we can do communication using blockchain. And wallet becomes, in some cases, wallet will be just the user interface. It might not have no logic, basically. You can have entire smart contract logic in the Ethereum blockchain. So when basically a smart contract is a program or collection of programs, and programs operate on data. So there is always a question where this data comes from. So one of possible cases, simplest cases, the parties themselves provide the data, like in the example with Bounty, it's kind of degenerate case. Then this data can come from a ledger, so it basically, if smart contract is executed in context of a blockchain, you basically have a list of asset prices, asset trades, so you can take that data and use it in a smart contract, if a blockchain allows that. And Bitcoin blockchain, you can't do that. And finally, you can take third-party oracle. So basically, let's say many practically useful smart contracts, we really want some kind of event in the real world to be used as a source of data. So let's say Alice wants Bob to paint a wall for her. And basically, a contract should automatically pay when wall is painted. So how does a program in the blockchain or in any computer can know when the wall is painted? Of course, it needs some external source. So maybe there is an inspector, some reputable party who can check in the real world, he can check that wall is properly painted, and he can then provide a signed statement that certain wall was painted. This data can be fed into a program on the blockchain, and basically then this contract can award the money to Bob. So this is the idea behind the Oracle. So basically Oracle can be anything which can provide this data in some form or another. A blockchain treats it as a black box. It doesn't know what is an Oracle. But of course there is the question like the quality of data in this case, because if data is bad, then of course smart contract will be useless. If source is compromised, smart contract will be compromised as well. So there are many ways to mitigate this problem. Like if you're dealing with, maybe there is a reputation system, so you keep track of all statements provided by an Oracle. So he has an incentive, maybe you incentivize him, you pay him some money for each statement he produces, so he has reputation at stake. Or maybe you can combine multiple Oracles together to improve the quality. Then there is, of course, hardware Oracle, so basically like hardware devices which can provide like check whether some seal was tampered with or whether like GPS coordinates and things like that. So this is basically better and more automated alternative to human inspector. And finally, you can have a crypto economic incentives. That is, you can incentivize users to provide this data, paying them money if this data is true. Of course, it's like very interesting because it can be fully automated, but it's kind of hard to design this kind of a system. Then another question is, what can be a subject of smart contract? Of course, the trivial example is cryptocurrency or tokens. On the blockchain, it's most obvious, but it can also work with, smart contracts can work with financial instruments, actual property in the real world, rights, and things like that. So basically, pretty much everything which, as long as people can agree on something, that can be used in a smart contract. So we have a model of how smart contracts work in general. First of all, there must be a human agreement, like what is asset, how do we keep the track ownership of the asset, and so on. Then we have execution of code on the blockchain or otherwise on the provided data. And finally, it's been enforced. On the blockchain, if you deal with digital asset, it's enforced automatically. If you have a real world, you need some kind of real world enforcement mechanisms, like legal system. Basically, yeah. Let's consider example how it can be enforced in the real world. This is a case which my company worked on. We had LHV Bank issued euro tokens on the Bitcoin blockchain. So then you can basically, then people can use these tokens in the smart contract on Bitcoin blockchain. And finally, somebody who got these tokens as a result of contract, he can exchange them for real euro. So you see here the bank enforces the smart contract results. Basically, bank takes data from blockchain and enforces it by offering people actual cash or money on their account. And yeah, the bank is basically reputable. The value of smart contract here is that usually like the person you might be dealing with might be not very reputable. You don't know him, but you know the bank, it's been around for some time, it's reputable, so you would rather have bank enforced it than deal with some random person. And another enforcement example, another project which my company worked on with Swedish Land Registry. So the idea is that we have agreement between Land Registry and banks and how platform works. Parties basically we deal with real estate sale. So parties communicate using signed messages according to a certain workflow. And then we basically, of the workflow, the real estate is basically being sold, its ownership changes. And the land registry, which is a government agency, will update its records, so it's basically the enforcement step. So here's overview of different kinds of enforcement. Of course, the most easiest way is self-enforcing. In the cryptocurrencies of tokens, you don't really need to do anything. The program will just update the ledger. Then you have you can enforce it using legal system, like actual contractual law. Then, of course, there is a question like, does it really make sense to use smart contracts if we still rely on legal system to enforce a smart contract? I think yes, because in many cases it makes sense because basically you still have formalized basically workflow, you still have formalized agreement, so maybe it will be easier for a court to award basically resources according to the contract. It's fully formalized, and yes, there is like one way to make it compatible with existing legal system is through pre-agreed arbitration. Basically, if parties signed a contract which says, legal contract, which says that they agree to a certain arbitration process, then in many countries it's actually legally enforced, and basically there is a certain arbitrator company who can decide on this case, and if an arbitrator agrees to honor the decision of smart contract, it will be automatic, and basically it can be resolved much more easier, basically, without really lengthy litigation. Then you have trusted authorities, like I mentioned, the bank or a government agency can do enforcement. And finally, crypto economics. Of course, it's still like unexplored area where you can provide some incentives for enforcement. Finally, a little bit about difficulties and limitations of the technology. So, like, we have basically three issues. Quality of data. So we have a principle garbage in, garbage out. So if data is garbage, if Oracle is compromised, then smart contract, even the smartest contracts, makes no sense. Then we have like enforcement in the real world. Of course, this is what I just mentioned. Still, in many cases, if you cannot enforce a contract, then it makes no sense to do it. And the last part is buggy code. Of course, if you have a complex contract, have something like code is law principle, like on the Ethereum blockchain, there are several big cases like the DAO. Basically, a lot of money was stolen. So this is we're still working on like better programming models, better verifiable programs, and so on. Yeah, so that's all. I can take questions in Russian.